is just a little update to the previous video. I had some complaints that nobody could see my face when I was talking, so I'm going to try and add a little inset with this face video in it. But basically, let's cut right to what I want to talk about today, and that is that we've decided to update or change the layout of the board we're going to have manufactured. So let me show you the old board that I talked about in the previous video, and then I will point out the new changes. I'm going to try to make this video a lot shorter than the previous ones, so hopefully you won't have to sit around and listen to me drone on too long. So let's start by looking at the board that I talked about last week, or at least a very close representation of that. The only thing that has changed is I added another connector onto each of these corners that mirrored or had the exact same pin out as the other connector, but just had the power and ground pins changed, and that was to allow it to connect to either a solid state relay board or a mechanical relay board, whichever one we wanted to. But after looking at the design and stuff, I decided that we could probably do a lot better than this. And one of the first things I wanted to look at was that these chips, the MCP 23017s, come in multiple different body configurations, and this is an SOIC, a small outline IC, but it also comes in an SSOP, a shrinked small outline package, which is a little bit smaller, and I figured if I used the SSOP I could probably get a couple of more of these on the board, and so basically that's what I did. So enter the new design. This board, it's a bit narrower, about almost an inch narrower than the previous board. It now has 8 of the port expanders on it instead of just 6, and the port expanders are set up a little differently. So I have a dedicated port expander, say in the upper right hand corner here. I have a dedicated port expander with an A and a B port, and a single connector that can be used as both the solid state or the mechanical relay interface. And I did that by putting a power pin, a ground pin, the 8 data pins, and then another power pin. So if you use the right hand 8 in this particular connector, you're working with a mechanical configuration. If you use the left hand 10 pins, then you're using the solid state connector. And I added another port on the top, but now this is a separate port that can be actually used to interface to other devices. So since I now have a total of 8 relay configured boards, I changed the end configuration so it would handle 2 4-port boards instead of a single one that handled a 4 or an 8-port board. And other than that, I removed a couple of the power and ground connectors because I just didn't have space on the board for them. I moved the LED board over. I added a jumper to remove 5 volts from the STM32 when you have the USB connected, because you really don't want to power that from 2 different sources. And that's pretty much it. I think the other thing we've changed from the previous one is we added 2-row connectors instead of single-row connectors to the input pins, and used a 2x9 configuration. These little triangles indicate pins that are going to be cut off and used as keys. So there's a different pin cut off on each one of them, and then there's a corner pin cut off on all of them. So the keys will only plug in, the connectors will only plug in one way, and they will only plug into one of these. So that way, if you unplug your cables and then want to plug them back in, you can't accidentally plug them into the wrong connector. And so that's it. We'll probably be ordering this in a week or so, and I'll come back when we get the parts and we're starting to build the connectors. So thanks for watching.